Good. Hello, everyone. Thank you for joining this talk on bringing reality into digital twins. I am Frank Suykens, and in Hexagon I lead R&D on visual computing. And for me, the first time that I heard about digital twins many years ago, it kind of showed something like this. An aircraft engine, a typical example, a CAD model that is actually designed up front with a number of sensors planned, and then the digital twin is really designed first. The physical twin is created from that design, and that's something to keep in mind for the remainder of my presentation. And such digital twins have proven themselves. They're quite common right now for predictive maintenance and other use cases. And at Hexagon, we wanted to assess the state of digital twins in our industries. And this report that you see here on screen was published October last year. Definitely worth checking it out. Contains a lot of feedback from over 600 C-level executives and provides super interesting statistics. And for my story today, I want to pick out statistics about the main challenges on digital twins. And the top two hurdles that came out for increased digital twin adoption were data quality and data integration and interoperability. And why does that come out? Well, for the traditional digital twin, like the aircraft engine, it follows a pattern that I call design and create. You design from scratch a kind of a digital twin, and from that you create the physical twin afterwards. And that works great. But one of the challenges is many, or maybe even most of the assets in the world have already been built, like factories or plants or cities that were built many years ago, but still having a digital twin of those still provides tremendous benefits. And you need another workflow for this. From the physical twin that was first, you need to measure it, you need to measure the world, model the digital twin from that. And this is actually where those challenges of data quality and interoperability come from. Because as you know, the real world, it's not a precise CAD model, it's full of unpredictabilities and imperfections. Luckily, that measurement and modeling is exactly where Hexagon excels. We have tons of software and sensors and platforms that help bringing the actual reality into the digital twin world. I will talk about this for sites. I will talk about larger scale things like cities. And I want to stress the combination there of advanced Hexagon technology, hardware and software, and the innovations we do that come into play for this. I want to show you as well something beyond sites and cities, including something that is cooking in our R&D labs at the end. So let's look at creating digital twins of an existing site or an existing factory or building. And you could, let's say, as a workflow, see it in 4 steps in this process. First, capture of reality, then modeling, creating a digital model from the capture, and then we start working with the model like simulation, but it could also be analytics or monitoring, and finally creating impact with that digital twin. First step, capture. Hexagon Live exhibition here is filled with examples of beautiful and accurate measurement sensors, high accuracy laser scanning, LiDAR providing millimeter level detail for intricate industrial environments, and combined with cameras capturing an enormous amount of imagery, the technology ensures that you can capture a complete and accurate measurement of your assets, no matter the environment, as you can see some examples on the video here. So this is what we capture. And then the raw output of most of these sensors is points and images. And this is where our software technology kicks in. The modeling step involves a lot of AI, artificial intelligence, for instance, to classify, to segment, to clean up the raw data, to assign meaning to the scan, and then advanced computer vision algorithms that we have turn this into an accurate geometric model that you see, and then combined with beautiful textures. And we invest a ton of R&D to get this modeling step from raw data to digital twin as automatic as possible with as little manual work as we can. And currently we're at the level where actually the digital model that we create from the sensor data can be used directly without manual effort in simulation use cases. And this addresses directly that data quality issue in digital twins by all this visual computing technology. So, third step, simulation or monitor and analytics. I have an example here that shows simulation of light transport simulation, where we apply super photorealistic rendering directly on the automatically created 3D model from the scan. So what you'll see here is HXDR, Hexagon Digital Reality, our cloud-native digital reality platform that manages both the raw captured data, but also manages the processing into a digital model. But it also integrates NVIDIA Omniverse. NVIDIA Omniverse also running in the cloud for that physically based lighting simulation, that super photorealistic rendering that we do then with Omniverse. And the interoperability between those two is ensured through the use of OpenUSD, so that we also tackle one of these interoperability challenges between different systems. Starting now, let's see it in action. So this is a Hexagon factory, and it is a real factory. So this is not just something we modeled. It's a real factory, captured, modeled, converted to OpenUSD, put into Omniverse, and rendered. And this, I love this example. It's the Breakers Mansion in Rhode Island. And apart from the scanning of this mansion and placing some lights then in the scene, there is no manual work involved. And many people actually do not believe that what you see here is the result of LiDAR capture, image capture, and from the raw sensor directly to the digital twin in a fully automatic way. And then we go to impact. Let's see if I can start the video here. So when you bring reality to digital twins, the end goal, of course, is impact. This video shows a construction example. So you see the data of the construction integrated into a geospatial context, a digital twin of the city around it. And then the design model is combined with the scan. So you see the scan here, the digital twin of the construction site, combined with the BIM model. And again, through automatic visual computing algorithms, we can compare reality with the plan and create, for instance, deviation analysis, which you see here. And the digital twin of the construction yard is, again, automatically generated, automatically compared with the as designed. And it's this level of automation that allows us and makes it manageable to do this process repeatedly and update your digital twin with new scans. And that approach can really save, within construction, a lot of time, a lot of rework. The quality and data integration provided by the Hexagon technology, such as HXDR or Cyclone 3DR, allow you to have a much better digital access to your construction projects as such. Then let's look at digital twins at a larger scale. Urban digital twins. The process here is similar. We start with capture, model, simulate, and impact. So we go from sensor to a digital twin solution as automatically as possible. Looking at the capture, it's this for a city, of course, at a much larger scale. You could use mobile mapping technology, for instance, our Pegasus TRK that's on the floor here, and an aerial data capture with Leica CityMapper 2 or other sensors can get you entire cities in a fairly efficient time frame to capture it. So once that data is captured, we can use our in-house LiDAR and photogrammetry technology to create beautiful urban models. We use AI to enable semantics in the scene, what is there, and what you're seeing actually here is we call it our super mesh technology, which actually allows a seamless integration of mobile data and aerial data to get a beautiful city model. This is a super mesh of Barcelona, combining data from Cyclomedia, mobile mapping, and from Leica CityMapper 2 into a single accurate digital twin of a beautiful city. Another example that I have here combines our Leica TRK mobile mapping data with aerial captures with our CityMapper 2. This is St. Gallen in Switzerland. And here you also see the detail of the mesh that is created, the accuracy of the geometry that is, again, created with a very high degree of automated computing. So once we have the model of the city, we can do things like simulation directly on this reconstructed 3D model. This example shows Klagenfurt, which is a very nice city in Austria. And yeah, look at the detail of the 3D model, which again automatically created. It can be used directly with Hexagon simulation and data analytics capability. For instance, in this example, airflow and heat simulation is done with our Cradle computational fluid dynamics simulation. So we can do airflow and heat simulation, and I'll show you some results here. What you see here is a heat map of Klagenfurt, and it's a real heat map. It shows you the heat in the city on a sunny day. At that day, it was, I think, an average of 30 degrees Celsius in Klagenfurt. And what you can see is fairly hot in the market, central market square here. And heat in a city, management of heat in the city is really a very growing issue and growing use case. This shows you a similar simulation, but now in a 3D environment with a semantic representation of the city. And this is called an LOD2 model, which again is automatically created through AI from the raw sensor data. And we also generate vegetation, for instance, like trees. And from this, we also generate 3D volumetric representations, voxel models, which are then fit for AI training, but also for interoperability with our fluid dynamics simulations. And why do we need that type of thing? Yeah, because things like wind play a critical role in the temperature management of a city. So let us simulate some changes in this urban digital twin. This simulation actually has six trees added in that market square. Those are the blue blobs that you see on top. And it shows the temperature delta. And obviously, if you put a tree in there, it lowers the temperature under the ground where the tree is. Phenomenon called shadow, so that's fairly trivial. But more interesting, actually, is the impact of this change in the city on the wind. So here we do wind simulation, and it shows, if you look at the left, it shows actually that you have more flow of air by placing the trees in that market square, even a couple of blocks away from where they are. So through this digital twin model and the simulation, we can really see the impact of changes in the city on that city. And this slide demonstrates what my colleague Georg Hammerer likes to call sensor to solution. Georg's team uses a whole chain of Hexagon technologies in this use case, all highly automated, to solve a use case and really going from capturing with the sensors to the through the solution and the impact for the city. So that's a simulation use case. How can we now assess actual impact on the city? This is also an example for Klagenfurt. This is captured in 2021, where we did simulation for solar potential. And of course, in a digital twin, you want to update the digital model from time to time. And here you see an update of the digital twin in 2023. And as you can see, tons of real solar panels added based on policies and guidelines coming from that simulation. So urban digital twins. And for bringing that reality into digital twins, in Hexagon we're continuously innovating. And key innovations that I mentioned are super accurate reality capture sensors, 3D reconstruction, HXDR as the cloud platform for easy management of that data, AI innovations, simulation through our own software or through trusted partners like NVIDIA, with great data interoperability implemented into HXDR, analytics, deviation detection, quality control at your construction site. So we keep innovating within Hexagon to bring that reality into digital twins. But I want to show you one thing more, and that is another level of digital twin. And this is showing green cubes done by our evolution, and it actually creates digital twin of forests, of the rainforest. And green cubes actually describe biomass in a forest at a stunning detail for sustainability purposes. And again, this is through aerial capture and advanced computing algorithms, but green cubes also does ground capture. So what you see here is with a BLK2GO, the rainforest is captured from the ground. And one challenge that Eric and team gave us as R&D is, okay, how do we model this digitally? How do we create a digital twin at the ground level of a forest? And this brings me to something that is, as I said, cooking in our lab. A new innovation that we are working on is the use of what is called Gaussian splatting. And it's a new way to represent and reconstruct reality, especially in visually complex situations such as a rainforest. So what you see here is actually not a video. It's a 3D reconstruction of a part of the rainforest, and then we just re-visualize this on a certain path. And it's amazing to see the detail that is reconstructed visually from the forest through the use of Gaussian splatting. Here's another example of Gaussian splats in a restaurant. And pay attention to the glasses at the top. You actually see the light behind those glasses change. This shows that accuracy, that visual accuracy that Gaussian splats can achieve. And together, what we want to do is, together with our reality capture sensors and our visual computing algorithms, we want to bring not just only visual accuracy with Gaussian splats, but also combine this with the geometric accuracy that Hexagon and our measurement sensors are known for. So stay tuned for this. This is coming in the future. Next level of reconstruction for digital twins. As I said, continuously innovating. We're moving towards digital twins of forests, but also digital twins of faces, which you can see for Aura, which we have here as well. New technologies that we're developing, Gaussian splats, but other innovations that are coming from our R&D engineers in the near future. Really trying to help you bring reality into digital twins. And we want to create foundational technology that can be applied in many, many different industries that Hexagon is active in, that you see here. So that brings me to the end. I hope I convinced you that, yes, Hexagon is a good partner to work with for digital twins. Thank you.